Today we are going to look at how to create realistic renderings of the planet Earth, or any planet if you want to, with the latest version of my atmosphere shader. Once you open up Blender, delete the standard assets and add a sphere. You will want to increase the subdivisions, like times 8, just so that once we render the image, the Earth will be smooth and there will be no shadow artifacts or something. Also make sure to turn on auto-generated UVs, because we will need those later on. Press right click and set to smooth shading, and then rename the sphere to Earth. Then open the properties panel and set the dimensions to 30 by 30 by 30 and press Ctrl A to apply the scale. Then we will copy the sphere and rename it to Clouds. This sphere will be multiplied by 1.0007, which is actually like pretty close to the actual height of clouds, so seems very low, but it's enough, trust me. And then we make another copy of that sphere and call it Atmosphere or Atmo, however you like to. And that one can be scaled up. It just needs to be like a little bigger than the other two spheres, but it doesn't really matter. After that, we switch to Cycles Render Engine, and now is also a good time to save the project. The next step after that is to append all the shader nodes from the file provided on Gumroad. So just click on File, Append, locate the .blend file, and open the Node Trees folder and import the Cloud Hemi-Combiner, the Clouds, the Earth, and the Spheric Atmosphere Barometric node files. Next up, go to the links provided in the description to download all the textures. The first three are from NASA, and you can actually get very, very high-res textures if you want to map the quadrant textures provided to the Earth. We're just gonna use the regular one, which is just one big texture, not quite as high-res, but in my opinion, it doesn't really make it too much of a difference for just the albedo map. Next up, we're going to download the topography map, which is going to provide height data, and lastly the cloud map for cloud rendering. And in both cases, download the high-res versions, and in this case, like for the clouds, even the hemisphere versions, because we will use the high-res ones. Then go to the last link and download the ocean mask. Back in Blender, open a new window for our shader editor and hide all of the objects except for the Earth. Then switch to the shader editor in the second window and select the standard material and rename it to Earth. Delete the principled BSDF node and add the Earth shader group. Connect both of the outputs to the corresponding inputs on the shader output. Select the node and press Ctrl T. Then you will open up the albedo map for the Earth. Duplicate the texture node. Connect it to the displacement. Open the topography map. Copy the texture node once again, connect it to the ocean mask input, and open the ocean mask. If you switch to render view now, you will see that we have a texture applied to our object, but it's very dark because we don't have any light source yet. So add a sunlight. Rotate it on the x-axis by roughly 78 degrees or something like that. And set its intensity to 10. Next, go to the world panel and decrease the background strength to 0. Next, enable the clouds layer again. Create a new material, call it clouds. Delete the principal shader, add the clouds shader group. Connect a texture coordinate node to the UV input. And open the shader node with tab. Go into the Cloud Hemi Combiner shader group inside the Clouds shader group and import the East and West hemisphere with their corresponding texture node. Now leave the shader group and set the coverage slider to 1. That will just make sure that the clouds are dense enough if you only use one layer to properly render. Then set the atmosphere to visible again, create a new material, call it atmosphere, delete the principal shader, add the spheric barometric shader group, and connect it to the volume socket of the shader output. For now, you can also turn off the clouds because they have a translucency shader on them and that takes up quite a lot of performance. So for editor performance, we will just turn them off for now. And as you see, you don't see anything. And that's because we have to set the first 3 parameters to the dimensions of the actual Earth in Blender. So 30 by 30 by 30, as we said in the beginning. There you can see it. And if you expand the shader node a little bit, you will see there are a lot of sliders, and many of these won't be immediately obvious to you, but I will go over them later on, and then it's hopefully clear what each one does. And as you can see, now our Earth renders correctly. Our atmosphere is also visible, and if we turn on the clouds, you can see we're mostly done. You could render the Earth like this and it would be correct. But since we don't want the bare minimum and this is also pretty slow to render, we will take a look at the render settings for now because we can still make a lot of improvements in render time just by changing those. So go to the render settings tab, change to GPU compute if you have a graphics card in your computer. This will greatly improve performance just by itself. Next, open the light path dropdown. Set the total bounces to 2, diffuse bounces to 2, glossy to 2, transparent to 5, and transmission to 2. Volume, we'll leave that at 0 because it only increases brightness but not really visual fidelity in this case. Set filter glossy to 2, turn off both caustics, and then go to the volume dropdown settings. Here you will want to set the step size to 0.01. 0.1 introduces some kind of stepping artifacts in some cases because we have a very shallow volume which doesn't like too big step sizes. But we will decrease the max steps to 12 because from then on after the visual difference isn't worth the increase in render time. You will probably find that setting these values correctly and according to what you're trying to render will offer the biggest performance improvements out of all the settings. Go to the color management dropdown and set the look to medium and above contrast, depending on how you like it best. I normally set it to medium to high contrast. Okay, coming back to the atmosphere shader. The first 3 sliders will control the density of the volumes. Like we have the air density, which is just general air. Then we have the ozone density and the ozone night glow. And it's just supposed to emulate the effect of green light in night shots of the atmosphere, which I saw on some photos. And next we have the density steam, which is just for general light scattering without color, which is caused by aerosol particles in the air and stuff. This like glowing of the sun in the sky is just caused by the steam in the air, and if you reduce this value to 0, you will see it disappears. If you set it up to 0.05 again, you will see it again. The next slider, the anisotropy steam slider, just controls how much this light spreads. So if it's supposed to be just a circle around the sun, or if it's supposed to be all above the horizon. I would suggest setting it to a very high number, like 0.95 or higher, just because it gives the most realistic results from what I could find through my research. And now we come to the actual parameters of the barometric equation, which is used to calculate the density of the air. So we have the planet radius, which is pretty self-explanatory. It's really just the actual radius of the planet you want to simulate. So if it's supposed to be as big as the Earth, you have to take the radius of the Earth and put it in there. We have the atmospheric density at sea level, which controls the atmospheric density at sea level. We have the gravitational constant of the planet, which just controls how far the atmosphere spreads into space. We have the molar mass of the individual air molecules, which also has an effect on how far it spreads out. And then we have the temperature at sea level, which again has an effect on how far the atmosphere spreads out. So if you want to create a new planet, just think about how big is it supposed to be, which temperatures would you expect, which density at sea level and stuff like that. Put it in, and it should be more or less correct. I can't speak for the atmosphere or the steam, because I didn't find any real values or formulas for calculating those, so they are just approximated. But generally speaking, this should work for every planet. Okay, now we're gonna have a look at the clouds again, because at the moment they're just a flat surface, and even though they have displacement on them by default, that isn't really enough to give the perception of thick clouds, and also light doesn't really interact with them that well. So if you want some more sophisticated clouds, just follow from now on, but basically you could also just use what's there already and continue with it. Also, using this techniques increases render time quite a bit, so if your system isn't that powerful, maybe stop here and just use what you have already. So if you switch to wireframe, you will see that the distance between the Earth and the clouds is very small, and also that we just have this just one plane atmosphere, and we want to extend on that, and for that we're going to use an array modifier controlled by an empty. So we will just go to the modifiers tab and add an array modifier, turn off relative offset and turn on object offset, add an empty, go to the empty control panel and increase its size so that we can more easily grab it once we want to move it around maybe, or scale it up and stuff like that. So now select the atmosphere again, go to the modifiers tab, click the eyedropper and select the empty. So if you zoom in now, you will see like there's not really much to see, but if we now select the empty and scale it up, we can see that we add layers to the clouds, and these layers in the end will look very great because they give the opportunity to to receive shadows and to diffuse the light coming from the side and everything, and that will make them look a lot more volumetric, and it's like a pseudo volumetric approach that just looks very great on the renders. You can see that I use those for all my renders, and you will see there's this fine orange line around the borders just because they have a little bit thickness and they shine through and everything, and that just helps. For easier handling, I suggest parenting the empty to the cloud object itself. Maybe call it cloud array controller or something like that, just so that you know which is which in the outliner too. And yeah, that's basically it. You will see at the moment the Earth isn't visible anymore. That's because we don't have enough transparency samples. So if that's the case for you at any point, just increase the transparency samples and then you should be good to go. Just as a quick side note, if you have the feelings that the clouds look a little bit too thick or a little bit covered too much, just go into the cloud hemi-combiner again, and on the cloud texture nodes, just change the color space from non-color to sRGB, and then the fall off is a little bit stronger, and that should help with that. Okay, I hope I covered everything, and I hope it's clear how to use the shader. These are a few examples of what you can do with it. If you want to see more or have questions, just leave a comment, or go to the Blender artist threads and just ask me directly, or however you want to. You can download it on Gumroad. If you want to support me, just maybe tip me with a little money. But you don't have to do that. Otherwise, just maybe leave a like or something like that. And yeah, have a great day.